Hey guys, this is Mrs. Shankar and I'm just going to go over this page on polarity and solubility with you guys. Now, polarity of a molecule is dependent on two things. A, whether or not the molecule has a polar bond like this one right here, CO2. The C and O are very different in electronegativity. The C gets to be positive and the O gets to be negative. The same thing here with the C and the O on the other side. This O is negative and this C is still positive. Now, even though this molecule has a polar bond here and another polar bond here, the whole entire molecule ends up being nonpolar because of the symmetric shape of the molecule. The linear molecule makes it symmetric. So when it's symmetric, the charges are evenly distributed and the bond dipoles cancel each other, and so there's no polarity. So this molecule has bond polarity but no molecule polarity. Now this molecule, on the other hand, the Cl2, it has no bond polarity, so obviously it's not going to have any molecule polarity. Now over here, if you look, even though the Lewis structure shows all the three atoms in a straight line, it's not a straight line molecule because of this lone pair over here. The lone pair kind of pushes away against the two SO bonds to make this an angular molecule, a bent shape. So the bond polarities don't really cancel out, and so this molecule will be polar. So it has polar bonds and an unsymmetric bent shape. So the unsymmetric bent shape will make sure that the bond polarities do not cancel. Okay. Now, how do you know if something is symmetric or not? So you look over here to tell if it's symmetric or not. So a lot of times when there's a lone pair on the central atom, that automatically pushes the molecule's bonds away to make a shape that's unsymmetric. So if it has the lone pairs, it's usually polar because the lone pair creates repulsion, resulting in an unsymmetric shape and an uneven charge distribution. If there's no lone pair, then you look on the either side of the molecule. Here there's carbon has no lone pair, but on either side it's just O and O, which means it's even on both sides. So it's nonpolar if there's no lone pair, and the atoms, if all the atoms around the central atom are alike and the charge distribution is even. Here in SO2, on the other hand, there's a lone pair on the central atom, so obviously it's polar. Now, if even one of the atoms on one side is different, the charges will become uneven and the molecule will be polar. So basically, if it's polar, it has positive and negative ends. If it's non-polar, it's just neutral. So if it's neutral, it's not going to dissolve in water. It's insoluble in water. But if it has charges, then the charges in the molecule will attract charges in water, and that molecule can mix with each other.